All right, pre-cal babies. All right, in this video, we're going to, it's kind of an intro into rational root theorem and finding zeros of your polynomials. So basically, we're going to talk about types of numbers here just to refresh your memory. So the first thing I want to do is look at this function right here. We have x to the fourth equals 16, and I need to find all the roots. Well, the easiest way to do this, since you can see it's a difference of squares, we're going to factor it. So I'm going to factor, this is going to be x squared plus 4, x squared minus 4, and then I've got another difference of squares, so I'm going to take x squared plus 4 and x plus 2, x minus 2. Now I want you to notice this is in a degree of 4. That means there are 4 roots for this particular function. But I only have 3 factors. So I'm going to set each of my factors equal to 0. And I'm going to solve for them. So I'm going to do these first because they're easy. Okay, so I know I've got 2 roots at -2 and +2. What happens with this third factor, when I solve this, I'm going to end up taking the square root of a negative. So over here on the left, the square root of x squared is x, no problem. But over here, this is going to be plus or minus the square root of -4. Now remember, one of our rules in math, we can't take the square root of a negative. Well, we can take the square root of a negative, but it's not going to give me a real solution. What it's going to give me is plus or minus 2i, because the square root of 4 is 2, and the square root of -1 is I. And we'll revisit this again in the next video. Just want to give you a heads up so that you are aware of the fact that we can have imaginary numbers in math. All right, so as we're looking through this, let's list these roots as zeros. So I can list my 2 as a 0 and my -2 as a 0, but I can't list plus or minus 2i as a 0 because it doesn't cross the x-axis. So I want you to notice that 2 of these roots are not zeros because of the fact that they are imaginary. That's why they can't be written as zeros. So they are imaginary numbers, and that means that they don't cross the x-axis. That also means they don't touch the x-axis. All right, so actually I should have used the word intersection. That's better. They don't intersect. All right, so let's talk about different types of numbers here. This should be familiar to you from little kid school. This rectangle is going to represent my real numbers. This is going to represent my imaginary numbers. And then over here, we're going to start from the inside and work our way out. So we're going to start with our natural numbers. Your natural numbers are the ones you naturally learn to count. 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. Then we look at whole numbers. Whole numbers include the natural numbers, but also include 0. Then we have our integers. Integers now include the natural numbers, the whole numbers, so 0, and the negative numbers. So the integers have the positives, the 0, and the negatives. And then we're going to look at the rational numbers. Well, the rational numbers now include fractions. So when I talk about a rational number, I could be talking about a natural number, a whole number, an integer, or a fraction. And then, of course, over here within real numbers, I have irrational numbers. So these are all the rationals, and these are the irrationals. So what makes an irrational number? These are your non-terminating, non-repeating decimals. So this is where your numbers like the square root of 2 live, pi, things of that nature. Things that have big, huge decimals that never end and they don't repeat. So not like 1/3, because 1/3 is just a rational number. Even though it's a decimal that goes on forever, it repeats the same number over and over again. So that's why it's not irrational. All right, so imaginary numbers, what do those consist of? Well, those consist of values where you've taken the square root of a negative and you get an I. So these are known as complex numbers. All right, so that leads us to why do we need to know this and why do we need the rational root theorem anyway? So up until this point, how have we found roots? Okay, haven't we factored? All right, we factor and then we set the factors equal to 0 and solve. Why can't I write? What the heck, yo? All right, so up until now, that's what we've done. We factored, we set the factors equal to 0, and then we solved them. So what if we have a quadratic and we can't factor it? Because that happens sometimes. Sometimes I give you a quadratic equation and it is not factorable. When you have a quadratic, that means it's in a degree of 2. We will use the quadratic formula when we can't factor it. And if you're unfamiliar with the quadratic formula, I'm going to show you what it is. There's a song. I know you're excited. La 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 la. Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. Now you'll never forget it. It's seared on your brain. You're welcome. Things you can't forget. All right, so what if our polynomial has a degree that's higher than 2? Because if the polynomial has a degree of 2, we can now factor or we can use the quadratic formula. But if we have a polynomial with a higher degree, and we've seen evidence that there's such a thing, what are we going to do? Well, enter the rational root theorem. This allows us to find all possible rational roots. Now, be careful. Notice this word possible. It will not give you a list of solutions. It will give you a list of possible rational solutions. What the theorem will not do for us is it will not give us the irrational roots or complex possible roots. So the reason we're talking about this is because in the later units or the later portions of Unit 2, we're going to learn how to solve a polynomial regardless of its degree and not using technology. So we need to understand that a polynomial can have all different kinds of solutions. It can have rational solutions, irrational solutions, or imaginary solutions. The rational root theorem will only give me a list of possible rationals, which means I've got to use other methods to find my irrational and imaginary solutions of a polynomial. Now, don't misunderstand, not every polynomial will have all of these. Some polynomials will have some of each. Some polynomials will only have 2 kinds. It just depends, and I'm going to show you how to do all this in later videos.